So welcome to today's class, Indices and Logarithms. Remember to subscribe and like. So we want to solve this for examples. It is combining, some of them are for indices, others are logarithms. So the first question, we have 49 x power 49 raised to power x plus 1 plus 7 raised to power 2x is equals to 350. So when you get such like question, first of all, examine that question and see if you can write all of them to the same base. If you cannot write all of them to the same base, then it means maybe there's some manipulations which you need to do, or maybe you need to substitute one of the index with a certain value, then eventually maybe it will form a quadratic equation, then you solve. So like here we have 49 raised to power x plus 1 plus 7 raised to power 2x is equals to 350. We realize that 350 you cannot write this on to base 7. So but 49 you can write it to base 7. So 49 it is 7 power 2, then into x plus 1 plus 7 raised to power 2x is equals to 350. If you expand the bracket, so you have 7 raised to power 2x plus 2 plus 7 raised to power 2x is equals to 350. Then in indices, when you see addition, it means the bases were the same, so it was a multiplication, so they added the powers. So you can break this one again, it will be 7 power 2x, then multiply by 7 power 2, so that when you multiply and you have the same base, so you just add the powers. So again, plus 7 power 2x is equals to 350. So at this point, since you cannot express this one to the same base, so we have said you examine that question. So now you have here 7 raised to power 2x, 7 raised to power 2x. You can let 7 raised to power 2x to be now y. Then come and substitute. So this one will be 7 power 2x is y, 7 power 2 is 49, so multiply by 49, plus 7 power 2x is y, so plus y is equals to 350. So this one will be 49y plus y, you get 50y is equals to 350. Divide by 50 both sides, so your y will be 7. So your y is 7, but we want x, so again come again and substitute. 7 power 2x is y, but your y is 7, so 7 power 2x is equals to y, which is 7, and you know 7 is the same as 7 power 1. So since you have the same base, so you can take the powers, so 2x is equal to 1. So x, now divide both sides by 2, so you find that x will be 1 over 2. So that question, you will have gotten the value of x. So the second question is for logarithms. We have log y base 3 into bracket square minus a half log y base 3 is equals to 3 over 2. So here you can express everything to the same base. Again, you can examine also the question and see that you have here log y base 3, again log y base 3, so you can use substitution method. You can say let log y base 3 to be x. So if this one is x, so it will be x squared minus a half log y base 3 is x equals to 3 over 2. So realize we have a quadratic equation, so you can multiply throughout by 2 to eliminate the fractions. So you'll have 2x squared minus x is equals to 3. So you'll have 2x squared minus x this to this side minus 3 equals to 0. So you can solve by any method that you want, factorization, completing square, quadratic formula, so that you can get the value of x. So here the sum is -1, product you have -6. So two numbers, when you add, we get -1. When you multiply, you get -6. These are -3 and 2. -3 and 2. So you have 2x squared minus 3x plus 2x minus 3. So common here is x. It goes here 2x minus 3. Common here is plus 1 into bracket 2x minus 3. So you'll have x plus 1, 2x minus 3 equals to 0. So the value of x1, x plus 1 equals to 0. So plus 1 to the other side, you get -1, then x2. So you'll have 2x minus 3 equals to 0. So -3 to the other side becomes positive, then divide by 2. X2 is 3 over 2. But still, we have not gotten the value of y. So you come again and substitute. You said log y base 3 is equals to x, but your x is -1, so -1. And again log y base 3 is equal to 3 over 2. So here your y, now you write it in index notation, so it will be 3 raised by -1, and here y will be 3 raised by 3 over 2. So you have the value of y. So the next question is about indices again. We have 2 raised by 2x minus 18 multiplied by 2 raised to power x is equals to 40. So the moment you have positives, negatives, multiplication, division in such like an equation, automatically you know, even if you express it to the same base and you have a negative, to not be easy to use that method whereby you take the powers, because powers you only use them when you are multiplying or dividing and we have the same bases. So here I use the substitution method. You can say let 2 power x be y. So it means 2 power 2x. 2 power 2x is the same as 2x multiplied by 2x. So that when you add the powers, it becomes 2x. So if this one is y, so here it will be y squared, because it is y times y. So y squared minus 18 multiplied by 2x, but 2x is y, equals to 40. This one is a quadratic equation, so you'll have y squared minus 18y minus 40 equals to 0. Positive 40 to this side, it has become negative. So the sum is negative 18, product is negative 40. So find two numbers. When you add, you get negative 18. When you multiply, you get negative 40. So we have 20 times 2, we get 40. So one of them should be negative. so negative 20 and 2. So that when you add, you get negative 18. So now you can simplify your equation. Y squared minus 20y plus 2y minus 40 equals to 0. So we shall have common term here is y into bracket y minus 20. Then common here is plus 2 into bracket y minus 20. We have y plus 2 and you have y minus 20. So it means your y1 is negative 2, y2 is positive 20. But we said let 2x is equals to y. So again you have to come and substitute. Let 2x is equals to y. So it means 2 per x is equal to negative 2. It's negative 2. Then the other side we have 2 per x is equals to 20. So you can introduce logarithm so that you can find the value of x. You can introduce log. Like this one, if you introduce log on both sides, it will be x log 2 goes to log 20. So if you want x, you divide by log 2 both sides. Then you get the value of x. The same applies to this one. Then the last question again is about indices. We have 3 raised to power 2x plus 3 plus 1 equals to 28. So if you look at this question, if you want to write to base 3, this one is 3 power 0. This one you cannot write it to base 3, so you take this one to this side first. You have 3 raised to power 2x plus 3 is equal to 28 minus 1. So you have 2x plus 3 is equals to 27. So at this point you can express 27 to base 3. So you have 3 raised to power 2x plus 3 equals to 3 power 3. So since you have the same base, just take the powers, you can drop the base. So you have 2x plus 3 is equals to 3. So you have 2x is equals to 3 minus 3. So 2x is equal to 0 and divide by 2 both sides. So your x will be 0. Your x becomes 0. So you can also try and prove and substitute. If you have 0 here, it will be 3 raised to power 0 plus 3, which is 27 plus 1 gets 28.